Hello, welcome back to our course Electronic System Design. So in the previous lectures, I had covered that I had covered these all topics. So today we will talk about the next topic, that is ESD protection. Okay, so that is topic 9. We will see today. So what is ESD in the sense means? The abbreviation for ESD is electrostatic discharge. So it is the release of static electricity when two objects come into contact. Familiar examples of ESD include the shock. Examples are, suppose this type of shock, that is a little bit shock we will receive from the carpet when you are walking across that, and touch a metal doorknob, and the static electricity we feel from clothes coming out of the dryer. Okay, so these are the little type of shocks you can observe. Coming to the definition of electrostatic discharge. Electrostatic discharge is the sudden flow of electricity between two electrically charged objects. So what it is meaning means, so ESD only happen, the static energy only discharge. So there is a sudden flow of electricity, which means which is pass like a spark. Okay, so only which type of object it will flows means only uh, electrically charged objects only this electricity will flows. More precisely, it is an electrical discharge from an electrical isolated material with a high potential difference that causes very short and high electrical current bursts. Okay, so prevently we can prefer it is a 3 kilovolts or higher. Electrostatic discharge. Due to electrostatic discharge, we can damage sensitive electronic components and lead to circuit failures. Okay, so that is the cause. That is the disadvantage of ESD. However, only a fraction of this voltage is needed to damage or destroy electronic devices. So this much of voltage only enough, or this much of 5 volts or 6 volts of energy is enough that will destroy our electronic devices. So ESD issues therefore must be considered in electronic system development to prevent system failures. As an electrical engineer who are working in the companies, they will check whether for a particular product electrostatic discharge test was done or not. So this is very important because without this point, we have to, without considering this point, we need to go to another step. Because if anything was happened means the overall system will get damaged. So the engineer cannot identify that problem, and it will take a lot of time. The product have to deliver in the market. So we'll see what are the main causes of ESD. So two materials I had already told with different energy levels from electrons are in frictional contact. Okay. So always the energy of the highest energy electrons at zero temperature will go to low. That is, they are subject to frictional forces between one another. The electrons are always tends to move from the materials with a high electron energy level to the material with a lower energy level. Because that what will happen? The charges are transferred between the bodies while they are in contact. The electron charges are unbalanced when the bodies are separated at this. Okay. So this point we will see with an example. So why the charges are very close in contact, then only the energy is the charges are transformed. Suppose the electrons are unbalanced means again the bodies will be separated. So this is very important point. Why? Because means surface is now electrically charged either negatively or positively. Any contact with uncharged objects such as grounded bodies. Main important. Every circuit was grounded body. I have to give them. So may cause electrical discharge of the built up static electricity. So an IST event can also be triggered by a process known as induction. So what is induction means? Suppose I'm taking some electronic components, they can be polarized. Polarized means either positive or negative. If they are in the vicinity, that is the source side uh, of an electric field. Okay, so in the source side, transmitter side, also some electric field will have the polarization of these electron components may cause the discharge of little bit of electricity. Such a field can come from equipment or feed belts that have been previously charged with electrostatic charge. So why it is happening means they are already charged with the previous components. Even though net electrostatic charge of the object is not changed, it is now region of excess positive negative charges. When components are separated from the object, for example, components from a feed belt, a potential difference is produced with the risk of ESD. Okay, so this is the figure we can see here. Uh, so this is the effect of charging by friction. So this is the effect of fraction by induction. Suppose two charged bodies are very close in contact. Okay, the high energy level is moves to zero. Then what will happen? The negative polarized body is coming out. Negative energy should be extended here. So we need to give it. Okay. Suppose the two bodies are separated at the victim side, then they are separated and they are affected by electric field at the source side. Then they will separate the polarities of the particular body what you are sending. So then again the negative polarized component, negative polarized should be grounded. So this is also major causes of VST. Electrostatic discharge (ESD) can damage microelectronic devices and consequently cause the device or the entire system to fail. Components can be severely damaged or partially degraded by a spark powers, so that we can lead to immediate failure or subsequent failure in the field. We can replace it, no problem, because the small components, ICs, are particularly susceptible to ESD. Okay, ICs are very susceptible. It can easily leads to electrostatic discharge, and it is one of the main cause of catastrophic damage to chips, as their typical cutoff voltage is between 5 to 30 levels. Measure need to be put in place to prevent even small amounts of static field. So, what is the suppression measures you need to consider when ESD is happening? So, some points are given for preventing this. ESD, safely discharging unavoidable plastic, parasitic static buildup, and minimize the buildup of electrostatic charge in the vicinity of electronic devices. While integrated protection circuitry ensures that static buildup discharged within the electronic components such as ICs and the EPA, electrostatic discharge protection area, comprise a range of protection measures for measuring handling these components. And EPA is classified for manufacturing areas are designed to prevent the static charge buildup. This is achieved by electrically conductive and grounded workbenches. So the cause of conductive filaments and garments worn by assembly workers. Okay. Conductive wicks and foot straps and floor covering, ionized air and the grounding of all the devices. So here, these are causes and suppression measures we had observed. Some other causes also I want to discuss with you. Human handling. Uh, Human handling is also one of the important points because we should take care about ourselves by covering all parts of our body. Interaction with the charged objects or tools. Environmental factors, that is low humidity conditions also will cause the ESD. ESD protection technique is mainly grounding and bonding using ESD safe materials. Protective devices like transient voltage suppressors, it has some suppressors like TVS, which is transient voltage suppressor, and diodes. So these two components help you to protect the circuit from the ESD zones. So mainly the ESD protection components are TVS diodes, metal oxide varistors, polymer ESD suppressor, PCP design guidelines for ESD. So every engineer should be trained how to suppress the ESD in working place. Suppose I want to tell you short trace length to protective components, which is having very small components like ground planes and the sensitive areas, controlled impedance path, HBM, human body model, machine models for component level testing. So these are some measures to suppress the ESD and how to protect the who are working in that place. They should wear the filaments on garments. So you should always warn assembly who are working in their place. They should wear all the garments, and who are working the benches like their working place. That should be electrically conductive and should be grounded. And this is foot straps or floor covering. Ionized air, the grounding of all the devices. Also, one of the important suppression measure. So I want to conclude this topic. Early ESG protection design improves reliability and productive longevity. So which means what? Anything, not only this ESG protection. Every measure, every test of a product only should be released in the market and it is stamped by CE designations. That is very important. We should look at out in the design process only. So when you are completed your product in the design and development process, that should be improves the reliability, right? Yeah, and product longevity, which means the product will be product life is very high. So that what we discussed in the first unit, the life of the product also increased. There are many stages after once release in the market means the competitors will ready to prepare another component like this, which means what? Then our product will be price will be decreased and we will get some loss. So to avoid these penalties, so our product should be having more lifespan. It should be work reliably entire their life. If any repair comes means it because of not for the product, it is because of human handlings. So that is very important task. You should be take care of for your products. Thank you. Next topic we will discuss